So, hello, my name is Joshua Macabuag. I'm a chartered structural engineer. I used to work as a design engineer, designing buildings in the UK, the Middle East, and other countries.
So I've also heard you described as a search and rescue engineer. What's that? I've never heard of that discipline before.
Yeah, it's fairly unusual, but I went to the Japan tsunami with something called the Earthquake Engineering Field Investigation Team. And that essentially led me down the path of becoming what I call a disaster risk engineer. So that basically means using, in my case, it's structural engineering because that's my professional background for the mitigation of disaster risk. So the humanitarian aspect would come into things like search and rescue, which is one of the things that I do. And there are different types of search and rescue. So my particular work is in urban search and rescue, which means finding people trapped in collapsed buildings and safely getting them out of the building. The role of the engineer in urban search and rescue is in trying to understand the least dangerous way to access and to extricate us and pull out the casualty. So when you have a collapsed building, that's a very dangerous thing. It's just a big pile of very heavy things that can move and fall and cause a lot of harm to the people inside and the people outside. And so your role as the engineer is to figure out the least dangerous way to get into that building or that rubble pile and get the people out.
I mean, that sounds to me quite difficult because I can imagine if you're designing a bridge that people are building to your plans in some way, that things are going to turn out in a quite nice, ordered way. But when you go to a building, presumably it collapses in a myriad of different ways, and your structures are not as neat and tidy. There's no blueprints for you to work from of what the building is once it's collapsed.
That's exactly right, yeah. So it's a very different mindset from the role of a design engineer. So a more typical engineering role would be someone has a concept for a building or a bridge or a stadium or some other form of structure, and then you figure out the way to make that idea stand up in the real world using real materials, columns, beams, steel, concrete, etc. Then your main job really after defining how to carry those weights and loads is to think of all the things that could go wrong, how your building might crack or fail or move or subside, and then think about ways to mitigate those risks, so to stop that from happening. And that's how you design your building. That might sag too much. Okay, well let's make that stronger. This column's in the wrong place. Okay, let's move it, but then that's going to cause other problems. Let's deal with those. The mindset for search and rescue engineering is a little bit different because, as you say, you don't really have very much information other than what you have in front of you. The other big difference is, whereas a design might take months or even years, you don't really have any time to find out much more than what you have in front of you. So, if there's somebody trapped inside a collapsed building, then you'll have minutes to decide the best way to access and extricate those people. And you don't really have anything other than what you can see with your eyes. And the ways that you can try to approach that problem is you want to get as much information as possible. So, you'll go around the structure, you'll take in as much information as you can. And when you're doing that, you're really trying to assess the past, present, and future of the structure. So what I mean there is when you have a collapsed building, just picture a big rubble pile of collapsed slabs and beams and roofs and a bit of a mess. Your first thought should be, are there any victims inside and where are they likely to be? Because that's where you need to focus your attention. And then for the structure, it's what did that building look like originally? So it was a three-story building made of reinforced concrete. It stood over here. Now it's collapsed and it's ended up over here. The collapse has likely been, from what we can see, it looks like it might be a failure of the ground floor columns on the west side, which has caused it to topple. And all that information tells you, okay, what it's made of, where it's moved to, which gives you information on where people are likely to be, etc. But also then to think about what would happen next. So if this was to fail further, could that slab that's there resting on that wall, could that wall fail and could it move further? If that was to move further, would that crush the people underneath? What can we do about that? Can we avoid that risk? Can we remove it? Can we mitigate it or can we monitor that risk? So yes, it's very different from your typical design structural engineering, but they very much lead on from one another.